Hello, my dear students. In the last class, I discussed how to draw Sfd and Bmd for overhanging beam. Let us take one more example. Um, Draw shear force and bending moment diagrams for the beam shown in figure. Indicate the numerical values at all important sections. Okay, this is the beam given, overhanging beam. You can see here the supports are at A and B, and this portion is overhanged. Okay, now what you have to do, first you have to find the reactions. How to calculate reaction? Take first vertical forces equal to 0, upward force is positive, downward force is negative. Okay, so what is upward force here? At A and B supports are there, so it develops reaction. So RA, that is upward direction, so plus RA, then RB upward direction plus RB, then all these are above the beam, that is acting in the downward direction, so minus 1 into 5. For calculation, to make it easier, I have converted this into kilonewton. Okay, now 1000 Newton per meter I have converted into 1 kilonewton per meter. Otherwise calculation is very difficult, and this 8000 Newton, so convert into 8 kilonewton. Okay, into 10 raised to 3, so that is nothing but kilonewton, and for kilonewton and 1.6 kilonewton per meter. Okay, so let us find now RA plus RB minus, this is 1 into 5 UDL, you have to convert into point load. For that you have to multiply it by distance, so 1 into 5, then minus 8 downward direction, minus 4 downward direction, minus again one more UDL, convert into point load. How? Multiply by distance, so 1.6 into 2.5, that is equal to 0. So RA plus RB is equal to 21 kilonewton. Then find, take moment about A or B and find any one of the reaction, RA or RB. Okay, I'll consider moment about A. Okay, so how you can write the equation? This is the load is there, here reaction, so this is acting in the anti-clockwise direction. Here this is anti-clockwise direction, it is moving like this, so anti-clockwise direction, anti-clockwise is minus. To find the reactions, okay, that is there is a difference between moment and bending moment. Now you are calculating only moment. Okay, so that's why this is minus RB into till A. What is that? 5 plus 2.5 7.5 plus 5 12.5, so minus RB into 12.5. Then next force is this is considered, and how this is acting in the downward direction, so about A it moves like this, so that is clockwise direction, so plus 1.6 into 2.5. okay, first you have to multiply by distance, 1.6 into 2.5, then this is force into perpendicular distance, you are calculating moment, so half of 2.5, that is 1.25 plus 5 plus 2.5 plus 5, that is equal to 13.75. I hope all of you understood how this is 13.75, because 2.5 divided by 2, okay, 2.5 divided by 2 plus 5 plus 2.5 plus 5. okay, so that is equal to 13.75. next is this load acting like this direction, so that is clockwise, so 4 into this distance, what is this? 5 plus 2.5, that is 7.5. next is this point load 8, again acting clockwise direction, so 8 into perpendicular distance 5, 8 into 5, then one more UDL is there, so 1 into 5 into half of 5, that is 2.5 equal to 0. So 12.5, simplify this, you get RB is equal to 11 kilonewton, RB is 11 and RA is equal to 10. How you get RA? Substitute in this equation, RA is equal equal to 21 minus RB, that is 21 minus 11 is equal to 10 kilonewton. So this is the first step. If you went wrong here, you don't get even single mark out of 20. Okay, so first step, you have to find the reactions properly. Okay, sign convention, just remember upward positive, downward negative, clockwise positive, anti-clockwise negative. Okay, next we'll find shear force. How to draw how to calculate shear force values. First find shear force at E, this point. What is that? There is no force, so shear force at E is equal to 0. Next shear force, just write to B, that is what? 1.6 into 2.5. This is downward direction, right side downward, that is plus. So plus 1.6 into 2.5 is equal to 4 kilonewton. Next shear force at B. What is that? Till here it is 4 kilonewton. So plus 4 minus RB. Why minus RB? This is right side upward, that is negative. So minus 4 minus RB. So 4 minus RB is equal to 11. So 4 minus 11 is equal to minus 7 kilonewton. Next, what you have to calculate, just write to D. What is that? Same thing, there is no loading, nothing. So it is minus 7 only at right to shear force right to D. Then shear force at D, what is that? Till here at D it is minus 7. Then again right side downward, that is plus. So plus 4, that is equal to minus 3. Then shear force, just write to C. What is that? Again there is no load, nothing. So it is minus 3 only. Then shear force at C, what is that? Minus 3 till here, minus 3 plus 8, right side downward plus 8 is equal to 5 kilonewton. Okay, then shear force right to A, what is that? Till here it is 5, see, 5 plus 1 into 5, it is equal to shear force is equal to 10 kilonewton. Okay, so shear force at A is equal to 10 kilonewton. Whatever the remains at right to A, that is equal to shear force at A, and always that is equal to RA. Okay, so this like this you can calculate shear force values. Then we will do how to calculate the bending moment. Then first let us consider bending moment at E. What is that? 0. There is no load acting at the point E. Okay, so and also there is no perpendicular distance, so bending moment at E is equal to 0. Next consider bending moment at B. What is that? Here this is 1.6 into 2.5 into, this is bending moment, so force into perpendicular distance. So 1.6 into 2.5 is the force, perpendicular distance is half of 2.5, that is 1.25. So this direction it will move like this. So this is right side downward, like this it is minus, right? This is plus, correct? So this is plus. So that like this direction it is. So minus 1.6 into 2.5 into half of 2.5, that is minus 5 kilonewton meter. Next find at D. What is that? Till here this is okay, first I have considered this UDL. So 1.6 into 2.5. Okay, UDL is acting only this distance. So multiply by 2.5. Then half of 2.5 plus 5, because you are calculating bending moment at this point at D. So 1.6 into 2.5 into half of 2.5 plus 5. Okay, so that's why here I have written like this. Then at D only, one more, this is the reaction here, RB, that is acting like this direction. So that is plus, so plus RB is 11 into 5, till D it is 5. Okay, simplify, you get 30 kilonewton meter. Next find at the point C, same thing. Again, first consider 1.6 acting in this direction. So minus 1.6 into 2.5 2.5 into half of 2.5 plus 12.5, plus 7.5. Why? 5 plus 2.5 till C we are considering here. So 5 plus 2.5, that is equal to 7.5. Then plus RB is 11 and direction is like this, that is plus. So plus RB into 7.5. 5 plus 2.5, 7.5 minus till C we are calculating. So 4 downward like this direction. So that is minus 4 into distance till C, it is 2.5. Okay, simplify this, you get 37.5 kilonewton meter. Next point is at A. Obviously it has to be 0, but still you have to write the equation. How you can write? First is 1.6 into 2.5 into half of 2.5 plus 5 plus 2.5 plus 5. So that is equal to 12.5. Okay. Then minus RB is 11 into 5 plus 2.5 plus 5, that is 12.5. So minus 11 into 12.5. Then again this load minus direction is like this, minus 4 into till A, 5 plus 2.5, 7.5 minus 8, this load 8 into 5 minus one more UDL is there, 1 into 5 into 2.5. That when you simplify that, you get equal to 0. Okay, now you have to draw Sfd and Bmd. So draw the diagram. What is at shear force at E is 0. At B it is 4 kilonewton. I have calculated here. At B 4 minus 7, 3 minus 3, 5, 10, 10. Okay, draw that 0, 4 minus 7, then again minus 7, write to D, and then write to C also, this is 7,000, then at D it is what is that, at D write to D is minus 7, but at D it is minus 3, so draw that minus 3 here, this is 3, okay, 3 or 3,000 here also at D. This is 3,000. Okay, then just write to C also 3,000. At C it is plus 5, so it is moving like this upward, plus above the line. Then 5 to it is 10. Here shear force at A is 10 kilonewton. So this is UDL. So it has to be an inclined line. Okay, draw this inclined line. Here it is 10,000. Okay, 10 kilonewton. Okay, like this you can draw Sfd plus. This is minus, this is plus. Then draw bending moment diagram. At A it is 0. At B it is minus 5. Okay. Then at D 30, 37.5, 0. Okay. So 5, 30 plus 30. So above the line 37.5. Then again at A that is 0. Okay, draw, this is parabolic shape here. This is curve. This is parabolic. Okay, this is parabolic. This is parabolic, and again this is parabolic shape. Okay, this is also parabolic shape, and this is a straight line. Okay, like this you can draw a bending moment diagram. Here where is the maximum bending moment? Positive bending moment occurs at B because shear force changes its sign plus to minus at B. But here we know already what is maximum bending moment, that is 5,000 minus 5,000. Okay, then you have to see where is positive bending moment maximum. That is here it is sign changes minus to plus, that is at C sign change to bending moment at C, that is plus 37.5 kilonewton. So this is positive bending moment. So positive bending moment occurs at C and negative bending moment occurs at B. So no need to calculate X and all, directly you can write the value because it occurs at the certain points only. Then point of counterflexure is there here. It is not asked asked in the question, if you want, you can calculate, okay, where bending moment changes its sign. This is minus, this is plus. That point is called as point of contraflexure. So let us, you can consider A to this distance is y, and find what is point of contraflexure. Okay, so like this you can draw SFD and BMD. Hope all of you understood. Thank you.